It was sum from n equals 0 to infinity, negative 1 to the n plus 1 times n factorial squared over 2n factorial. We want to see whether this converges absolutely, conditionally, or diverges. So I'm going to look at the absolute value of this. So I'm going to get rid of the negative 1 to the n plus 1. I'm only going to consider this for now. And in order to solve this, I have to use a ratio test. So I'm going to take the limit of the n plus first term and then divide it by the nth term. So we have n plus 1 factorial. So this is what I'm going to do. I'm going to pair these guys up. So these two go together, and then these two will go together. So n plus 1 factorial squared over 2n factorial. Over n factorial squared, I mean. And then 2n factorial over 2n plus 2 factorial. So then we can bring it inside the square here. So we can have n plus 1 factorial over n factorial squared. And then here we have 2n factorial, and the denominator will just be 2n plus 2 times 2n plus 1 times 2n factorial, which the 2n factorial is going to cancel. And then n plus 1 factorial is just n plus 1 times n factorial, and the n factorial is going to cancel. So we have the limit, n approaching infinity, n plus 1 quantity squared times, I'll just put that in the bottom, or over 2n plus 2 times 2n plus 1. I'm going to expand this and multiply the denominator. So we have n squared plus 2n plus 1, 4n squared plus 6n plus 2. I'm going to divide everything by n squared to get 1 plus 2 over n plus 1 over n squared over 4 plus 6 over n plus 2 over n squared. And then a lot of things are going to cancel. So, well, 2 over n goes to 0, 1 over n squared, 6 over n, 2 over n squared all go to 0, and I'm left with 1/4. Because this is positive, it's less than 1. This converges by the ratio test. And I was looking at the series with the absolute value, so this converges absolutely, and that is due to the ratio test.